Welcome to Study Loop.
Problem 9. The rank problem is solved as the smallest value will rank or will receive rank 1, the second smallest value will receive rank 2, and so on. If there are two values that are equal, then the rank is the average of the corresponding ranks. So to determine the difference in ranks and the square differences, we get that sample 1 is 580, 580, 270, and 470, and 420, and 415, and 330, and 430. The rank for sample 1 is 7.5, 7.5, 1, 6, 4, 3, 2, and 5. And sample 2 is 205, and 225, and 285, and 270, and 185, and 215, and 185, and 220. So the rank is 3, 6, 8, 7, 1.5, 4, 1.5, and 5. So the difference rank is 4.5, 1.5, negative 7, negative 1, 2.5, negative 1, 0.5, and 0. And the square differences is 20.25, 2.25, 49, 1, 6.25, 1, 0.25, and 0, where the sum is 80. So the Spearman rank correlation coefficient can be calculated as 1 minus 6 times the summation of b squared, which is 80, over n, which is 8, n squared, so 8 minus squared minus 1, which is approximately equal to 0.0448. So to determine the hypothesis where the h node is that rho is equal to 0, and the h1 is that rho is not equal to 0. So accordingly, we can define the critical values from table L corresponding to row n is equal to 8, and column alpha is equal to 0.5. So the critical value is equal to 0. Positive or negative 0.738. So if the value of the Spearman correlation is between the two critical values, so we fail to reject the null hypothesis, else we reject it. So here the critical values, our correlation is between the critical values, so we fail to reject the null hypothesis. So for question E, finally we can say that there is no sufficient evidence to say that there is a linear relationship between